Hello everyone. Today I am here to present on the topic non-ferrous material. It is a part of manufacturing process, and so let's get started. The topic which I will be covering is non-ferrous material and non-ferrous material and different types of non-ferrous material. So first of all, introduction. Steel and other ferrous. Why we require non-ferrous material? So importance of that. Steel and other ferrous alloy are consumed for exceedingly large quantities because they have a such wide range of mechanical property, may be fabricated with relative easy and are economical to produce. However, they have some distinct limitation also. Chiefly, number one, a relative high density. Number two, comparatively low electrical conductivity. And number three, inherent susceptibility to corrosion in some common environment. Thus, for many applications, it is advantageous or even necessary to utilize other alloys having more suitable property combination. That those alloys that are so brittle that forming or shaping by appreciable deformation is not possible or ordinarily at cast. These are classified as cast alloy. These alloy are attended to mechanical deformation are termed as wrought alloy. Okay. So properties of non-ferrous material, those are properties of copper and alloy. Non-ferrous material, actually those are material which do not have carbon atom as its main constituent. Properties of copper and alloy: FCC structure, soft, ductile, tough and difficult to machine, can be cold work, good corrosion resistance in diverse environment including ambient atmosphere, seawater and some industrial chemicals, high electrical and thermal conductivity, radiation color and non-magnet, antibacterial, easily joined by brazing and soldering, low strength to weight ratio than aluminum and magnesium alloy, better resistance to fatigue, creep and wear than aluminum and magnesium alloy. Usually alloying element added to copper are zinc, aluminum, P, B, silicon, nickel, manganese, magnesium, iron and Pb. Alloys of copper are brass alloy of copper and zinc, bronze alloy of copper and several other elements including tin, aluminum, silicon and nickel. So basically these two are coppers of alloy, brass and bronze. First of all, bronze. Aluminum, bronze, alloys of aluminum and copper in which copper is base metal and aluminum is alloying element. Commercial aluminum bronze contains 4 to 11% aluminum. Other alloying elements like iron, nickel, magnesium and silicon may be added. The properties of bronze are good strength, ductility and toughness. It has good bearing properties. It has good corrosion resistance, good fatigue resistance. These alloys are lustrous and their color is the finest of all copper alloy and hence they are frequently named as imitation gold. Okay. Alloy with 4 to 7% of aluminum, single phase alloy, can be fabricated by cold working process such as drawing, pressing, rolling, etc. because of their good ductility and malleability. Okay. The properties are: in annealed state they show tensile strength of 35 megapascal with elongation over 50% and hardness in the range of 80 to 90 bpm. Application: it is available in sheet, plate and tube form and are used in jewelry, cigarette cases, heat exchanger, chemical plant, etc. Alloy with 8 to 11% of aluminum, two-phase alloy, can be cast, hot rolled or forged. These properties are sand cast alloy, show tensile strength of 45 to 55 MPa with elongation between 20 to 30%. Hot worked alloy should show better mechanical property not only at room temperature but also at elevated temperature. Its application are pump casting, valve fitting, propellers, cylindrical heads, gear ties, bearing, spark plug, bodies and electrical contract. Next is tin branch. Here I have a table. I have made it tabular form so that it is easily understandable to you all. Tin branch, name, composition and use. Okay, so coinage branch, it is composition is copper 94%, SN is 5%, zinc is 1%. It is used in manufacturing of coins. Next we have gunmetal. It is very important, gunmetal, because it has come in the university exam also 2-3 times. The composition is copper is 88%, SN is 10%, zinc is 2%. It's used in gun barrel and ordnance factory parts, marine casting, gear, bearing, valve bodies and similar application. Next we have phosphor bronze. Wrought phosphor bronze 2.5 to 8%, P is 0.1 to 0.3, rest is copper. It is used for manufacturing of spring, wire gauge, wire brushes and electrical contract. Statuary bronze, copper is 86%, silicon 10%, zinc is 2%, PV is 2%. It is used to make statues. 80-10-10 bronze, it is used, the composition are SN 9 to 11%, PV 8 to 11%, rest is copper. It is used to make high speed heavy pressure bearing and bushing. 8555 bronze, ounce metal, it is known as ounce metal. Copper is 85%, silicon SN is 5%, zinc 5%, rest is PV 5%. Bearing, low pressure valve, taps and pipe fitting, small bearing. Okay. Next is beryllium bronze. You can see the picture also. Beryllium bronze contains 1.5 to 2.5%. Beryllium bronze, which is responsible for precipitation hardening treatment. Solid solubility of beryllium in copper is 2.1% at 864 degrees centigrade and decreased to less than 0.2% at room temperature. Precipitation hardening treatment, heating the alloy at around 800 degrees centigrade for half an hour and quenching in water. Okay, and this is the process of hardening treatment. Code working to improve the tensile strength, heating the alloy at around 300 to 320 degrees centigrade for 1 to 2 hours. By a combination of code work and precipitation, the alloy with about 2% be shown tensile strength of 1300 megapascal and hardness of 350 BHN, Brinell hardness number. Property, the properties are good corrosion resistance, fatigue resistance, high resilience, good bearing properties and non-sparkling characteristics. Its application is spring, diaphragms, flexible bearings, gears, bearing. Certain tools like hammer requires hardness and non-sparkling characteristics, mode for forming plastics. Next is silicon bronze. It is an alloy of copper and silicon. Solubility of Si in Cu is 5.3% at 845 degrees centigrade and decrease to less than 4% at room temperature. Si content in this alloy varies from 1 to 5.5. Elements like magnesium, Mn, Fe, zinc, Sn and Pb are added to increase strength and machinability. Properties, it has the following property like high resistance to corrosion, high tensile strength, high toughness, cheaper than tin bronze, can be cast, cold work and hot work. It is produced in the form of strip, plates, wire, rod, tubes, pipe and casting. Application is high strain bolt, rivet, spring, propeller shaft of marine vehicle, bells, handrails, fountain bowls, etc. Next is properties of aluminum in its alloy. FCC structure, ductile and malleability, can be hot work and cold work. Light in weight, its density 2.7 gram per cubic centimeter. Good thermal and electrical conductivity, it carries more electrical than copper. Excellent ability to get alloyed with other element. Some alloy are responsible to precipitate hardening, some have excellent castability. Okay, non-magnetic, no sparking characteristics, high reflective for the heat and radiant energy, powerful deoxidifier. Now aluminum alloy, I have made similar tables of aluminum alloy. These are magnesium composition is aluminum 94.5%, manganese 5%, and manganese is 0.5%. Properties: high corrosion resistance, machinability, surface finish, good strength. It's used in marine application. Duralumin, it has come 2-3 times in university exams, so you can consider it important. Its chemical composition is 94%, aluminum, copper 4%, magnesium, aluminum, silicon 0.5% each. Its high strength, tensile strength after precipitation hardening, good electric conductivity. It is used in aircraft industry and in the form of sheet, tubes, rivets, board, plate, etc. Next is Y alloy and vanadium. Vanadium actually used in aero engine component. Next is properties and application of magnesium and its alloy. Its property: SCP structure, light in weight, low melting point 650 degrees centigrade, high strength to weight ratio, good damping capacity, relatively high thermoelectric conductivity, good dimensional stability up to 100 degrees centigrade. Precipitation hardening after cellular treatment of magnesium alloy improves hardening and strength, while the hardness decreases by marginal amount. Its application is wrought form of magnesium alloy are used in aircraft fuel tank, duct, wing, flank in the string. The extrusion are used in the seat frames. Cast form of magnesium alloy are used in jet engine parts, landing wheel, helicopter gearbox. Also used in handheld devices like chainsaw, power tooth, hedge clipper, in automobile steering. I have given this diagram. Property: application magnesium in its alloy, chainsaw, saws we have, hedge clipper we have, wheels we have, and seat frame we have. Property and application of titanium and its alloy. Okay, so you can see the properties of titanium. Density of titanium is midway between aluminum and steel, high melting temperature, high electrical modularity. It is a high tensile strength also. Its application is airplane structure, space vehicle, surgical implementation, and petroleum and chemical industry heat exchanger. And the property application are in the heat exchanger of titanium alloy. Basically it is used to manufacture heat exchanger. Properties of nickel and its alloy: FCC structure, ductile and malleability, white in color, good resistance to corrosion and oxidation, good electrical conductivity, good ability to alloy with other material. And nickel alloy, I have made similar tables of name of component. Dura nickel composition I have given. Properties: age hardenability, good corrosion resistance. It is used in laundry clips, jewelry parts, optical frames, diaphragm, bells, fish hooks. Okay, next is a Hastelated D. It's a good strength, toughness, high hardness, difficult to machine are its properties. It is used in evaporated reaction vessel, pipelines, and fitting in chemical industry. And then we have Invar. Invar is a material which is used in length standard measuring tapes, instrument parts, variable condenser, turning fluffs, and special spring. Its composition is nickel is 36%, carbon is 0.2, and magnesium 0.5, rest is iron. It's zero efficient of thermal expansion in the range of 0 to 100 degrees centigrade. Thank you everyone. With this I come to end of non-ferrous material.